Hi everyone, welcome to the FI APM learning series. This is chapter 2. In this chapter, we will discuss how APM functions as an authorization server using the OpenID Connect Code Flow. I strongly recommend watching chapter 1 to understand OpenID and OAuth before watching this video. Alright, let us get started. In step 1, let's see how the user connects to myapp.lab.ae. The user opens secure web application, which is https://myapp.lab.ae:5000 from the web browser. The user request reaches to the web server. In step 2, let us see how myapp application validate the request and redirect the user to OAuth Authorization Server for authentication. myapp receives and checks the incoming user HTTP request. It found it is a new request and myapps need to know who the user is. But the user request does not contain any user identity information yet. Since this is publicly accessible secure web application, the user must be authenticated to access protected resources. At this point, the user is not authenticated. So, myapp application redirects the user to authenticate using OAuth Authorization Server. The question is, which component does this redirection? In our case, myapp is configured as both an OAuth Client and OAuth Resource Server. If the user is not authenticated, the OAuth Client role is responsible for redirecting the user to OAuth Authorization Server for authentication. For this redirect, the OAuth Client configuration includes the following details, which is Authorization Server URL, then Client ID, then Response Type, then Scope, and Redirect URI. Let us discuss each one in detail. Authorization server URL is nothing but the authorization endpoint which is going to authorize the OAuth client. The client ID is unique identifier for the client to connect and register the client to the authorization server. Response type specifies what type of response the client expects from the authorization server. In our case, since this is web application, we are using Authorization Code Flow, which is considered as the most secure method. Scope defines what information will be retrieved after the successful authentication and authorization. Redirect URI is the URL where the client will be redirected after successful authentication. In our case, we have configured the OAuth client, which is our myapp web server, with all the details, and it is redirecting the user to OAuth Authorization Server. In step 3, let us see how OAuth Authorization Server receives and verifies the OAuth client request. OAuth Authorization Server receives and verifies the OAuth client request in the following order. Is the OAuth client ID is valid? Is the OAuth response type is correct? Is the OAuth client registered for this service? Important note, for the client to be properly registered, the client redirect URI must be added to OAuth Authorization Server's client configuration. If any of this check fails, the OAuth Authorization Server will return an error. In our case, the OAuth Authorization Server successfully verifies the OAuth client request. In step 4, let us see why the successful OAuth client request verification prompt for the user authentication. As you know, the OAuth Authorization Server successfully verifies the OAuth client request already. This means it is a valid request from a trusted OAuth client, and the authorization server now needs to generate a response. To do that, it requires user identity details, which it doesn't have yet. So, the authorization server prompts the user for authentication to collect those details. In our case, form-based authentication used for this step. In step 5, user types his credential and submit to the authorization server for the authentication. In step 6, the OAuth Authorization Server receives the user credentials and verify it with Active Directory. The user authentication is successful. But this is not enough because myapp application wanted to access the user data like profile and email. So in step 7, the authorization server displays a consent screen to the user and asking for approval. The consent message is, "Hey user, myapp.lab.ae wants to access your email and profile. Do you approve this?" User can either approve or deny. If the user denied the access, they redirected back to myapp.lab.ae with an access denied error. In our case, the user is authorized this consent. Since the user authorized the consent, in step 8, the OAuth Authorization Server issues an authorization code and redirects the user to the myapp.lab.ae redirect URI. The OAuth client receives an authorization code via client browser. In step 9, the OAuth client creates the back channel to connect the OAuth Authorization Server to obtain the access token and ID token. In OpenID Connect, the ID token is mandatory because it contains the user ID information, and this is essential for user authentication. To get the access token and ID token, the OAuth client sends a post request to OAuth Authorization Server's tokens endpoint. This post request includes the authorization code received from the previous step, the client ID and client secret for authentication, the redirect URI. It must match the one which we used earlier, and the grant type, which is the authorization code flow. Important point to note here. As you know, the OAuth client connect directly to the OAuth Authorization Server using the back channel. And the purpose of this connection is to obtain the access token and ID token. So this connection must be secure. For the security, we use SSL communication between the OAuth client and the OAuth Authorization Server. In case if you are using self-signed certificate in Authorization Server, the myapp server must trust the Authorization Server's SSL TLS certificate. To trust this, the Authorization Server's root CA certificate must be installed in the myapp server's trusted root certificate store. Most of the deployment fails due to this. In step 10, the OAuth Authorization Server validates the OAuth client token request, and upon the successful verification, it issues access token, ID token, and reference token to the OAuth client. This token can be either JWKS token or OPAC token. Important point to note here. When OpenID Connect is enabled on FI APM, both the ID token and the access token must be issued as JWKS token. Because opaque access tokens are not supported by APM in OpenID Connect mode. Let us understand what is access token, ID token, and reference token. Access token used by the OAuth client to access protected resources on the resource server. ID token used by the OAuth client to verify who's authenticated. Reference token used by OAuth client to obtain new access token when the current one is expired. In step 11, the OAuth client passes access token to OAuth Resource Server to access the protected resources. Let us see this in detail. Once the OAuth client receives the access token and ID token, it sends a request to OAuth Resource Server to access protected resources. This request includes access token. In our setup, the OAuth Client and the OAuth Resource Server are the same application. This is common in modern web applications. In step 12, the OAuth Resource Server receives the access token. Then it verifies their JWT signatures using the OAuth Authorization Server JWS endpoint. Let us see this in detail. OAuth Resource Server receives the token from OAuth Client and checks the tokens. It is JWT token. The OAuth Resource Server verifies the JWT signature using the OAuth Authorization Server's public key. This public key is stored at the OAuth Authorization Server's JWKS endpoint, which must be reachable by the OAuth Resource Server. If the JWKS endpoint is not reachable, the OAuth Resource Server cannot verify the signature of the access token and will respond to the client with 401 unauthorized, which result access denied to the user. If the JWKS endpoint is reachable, the resource server downloads the public key and validates the token claims. Part of this validation, it makes sure the issuer is the authorization server. Also, it makes sure it is issued to this resource server. Also, it ensures the token has not expired. Also, it ensures the token has includes the required permissions. Once all checks pass, the resource server processes the request and serves the protected resources. This concludes our chapter 2, where we discussed how the APM functions as an authorization server using the OpenID Connect Code Flow. Please continue watching chapter 3, where we will learn how to configure and test the FI APM as an authorization server using OpenID Connect Code Flow. Thank you for watching.